Hello everyone, welcome to this session on linear algebra in machine learning. Linear algebra is at the core of machine learning. You all know that machine learning is actually at the intersection of mathematics and programming, right? The patterns that are identified in machine learning are expressed in the form of numbers and equations, which is nothing but linear algebra. For solving simple problems, we can do it using traditional methods, which we are going to see shortly. But when you have complex equations, large data sets, the equations are better solved through linear algebra, right? So linear algebra is at the core of what we do in machine learning. Many of the people in machine learning are not aware of this because we use libraries a lot. Libraries contain programming that corresponds to linear algebra, right? We don't get to see the equation that is happening inside a library. Hence, we don't understand or appreciate the importance of linear algebra in machine learning, right? So this is the diagram I drew. As I indicated, machine learning is at the intersection of mathematics and programming. So I have a simple scenario, y and x. Y is my dependent variable and x is my independent variable, right? So I have these two. I've just taken two data points. Okay, you can have 10 data points or 1,000 data points or even 100,000 data points. Okay, for explaining this concept, I have taken just two data points, right? So how will you fit an equation for these two data points? So this is a case of linear regression, right? And that too, it is a simple linear regression. So that is the equation that will fit for these two data points. Okay, that equation is known as the goodness of fit. Okay, now what is the equation that we will fit? It is nothing but y equals mx plus c. I've got the value of y and x. I need to find m and c so that I can predict future data points. If I know the value of m and c, I will have an equation, and using that equation, I can predict future values of uh, y for a given value of x. Right? That's what happens. You will be provided with x, you need to predict y. Right? That's what happens in simple linear regression. So how will you write this y equals mx plus c, in the form of equation? I have two sets of data, right? 2 and 6, 4 and 10. So I will substitute the value of 2 and 6 in this equation, 4 and 10 in this equation. So I have two equations, right? 2 equals 6m plus c, 4 equals 10m plus c. I can solve this equation and find out the value of m and c, right? Simple data points. I can even do this calculation by hand, right? As I said, when the complexity increases, when you have more data points, right, when you have higher order equations, this problem, solving for m and c or solving for error term, slope, whatever you call it, is better handled through linear algebra. Okay, so how will you express this equation in the form of linear algebra and how you will solve it? That's what we are going to see now, right? So I will express this particular equation like this. This is matrix, right? Some of you might remember from your 10th or 12th class experiences. 6 and 10 corresponding to these two values. This is 1 1, right? 1 into c, 1 into c, right? So I am putting 1 1 and then multiplied by m into c. So I have 2 into 4. That equals 2 and 4. So I have represented this in the form of a matrix, right? You understand this one? That one is nothing but 2 equals 6m plus c into 1, right? 10m plus c into 1. So that this one comes from here, right? So let me write this so that it is clear to you. 10 into m plus c into 1, right? That's why I have 1 and 1, 6 and 10 from here. I multiply by m and c, I have the answer 2 comma 4. So now I have to solve for m and c. So how will I solve for m and c? So mc equals 2 by 4, 2 and 4 rather, not 2 by 4, into this matrix to the power of minus 1. What does minus 1 indicate? Inverse, right? This is nothing but inverse, okay? And if you see, this contains only one column and two rows, right? This contains two columns, two rows. This is a 2 by 2 matrix. So this is a multiplication involving matrix of unequal sizes, right? So how will you go about it? You need to multiply these two and take into account this inverse, and you will have this answer for M and C. Okay, I'm not going to explain how will you actually do the computation, right? As I said, this is part of high school mathematics, right? I'm sure those who are in your colleges studying machine learning would have gone through this grind and rigor, okay, in your high school, right? Some of you might have studied in standard 10 or level 10. Some might have studied in 11th standard or level 11, right? Mathematics in high school and beyond linear algebra is an essential component, right? So now I will introduce an additional complexity. See, I have only 2 data points. What if there are 4 data points, right? How will you express this in the form of an equation like this? Because see, I have to find only 2 values, right? So I need to have this matrix as a 2 by 2 matrix. I cannot have a higher order matrix. I cannot solve it, right? Because here I only have 2 elements to find. So these two, right? This has to be a 2 by 2 matrix, and this has to have only 2 elements here. That is a necessity. But I have 4 sets of data. So how will I accommodate? How will I accommodate? For this, I will use this equation. N summation of xi. This is summation of xi here, and this is summation of xi square, right? Here I will write yi, sigma xi yi. Sigma is nothing but summation, right? When I say I equals 1 to n, it means if there are 4 elements, it means you add x1 y1 plus x2 y2 plus x3 y3 plus x4 y4. That's what this means, right? If I say sigma I equal 1 to 4 xi yi, this means x1 y1 plus x2 y2 plus x3 y3 plus x4 y4, right? This appears very elementary, right? For some this is elementary, for others it may not be, right? That's why I am explaining this, right? So far so good. Now how will you handle this programmatically? You can't be doing hand calculation, right? You can't be doing hand calculation like how you did in your high school. You will have to solve for M and C, be it 2 sets of data, 4 sets of data, or 10,000 sets of data. You have to use programming, because you can't be doing through hand calculations or by calculations that are not efficient, right? When it comes to programming, we are talking of efficiency, right? It's not just about knowing the theoretical aspects of mathematics. It is not just about converting it into a program, but having it in a program that can be deployed across multiple solutions, right? That's what we are interested. So having the right set of programs for solving MNC is very, very essential, right? So before I come to how you will identify MNC, let me talk of, I want to highlight, I want to talk about how will you handle a higher order equation, right? In this, it is only mx, right? What if it is x square plus x cube plus x to the power 4, right? so on and so forth. What we have? A polynomial equation, right? A higher order equation. How will you do it? You have to go for higher order matrices, right? X1 square, X1, and so on and so forth. This is how you go about it, right? Is this clear to you? Now, how will you go about doing programming? I've explained using a simple array 1, 2, 3, 4. Okay, I'm calling this as A. By using scipy.linalg, LINALG, which stands for linear algebra, okay, you can import this library and you can use and you can do all the computations and calculations, right? What does this stand for? This stands for inverse, right? What is this AT transpose? What does this stands for? Transpose. What is this? This is multiplication, right? I have an array, I'm printing it. Now I'm doing inverse, I'm doing transpose, and I can also do multiplication, all with the help of scipy.linalg, right? Linear algebra. Very easy, right? So this is how you solve a linear algebra problem. As I said, our data points are expressed in the form of matrix, right? It can be a simple scenario like what I explained, or it can be a polynomial equation like this, or it can be a logistic regression, right? Or it can be a neural network. For everything, we will be using a matrix, right? We will be using the concepts of linear algebra. You don't get to see this because all the computations and the associated programming are behind a library. By using a library like sklearn, right, we solve all the problems in machine learning. But what goes on inside the machine learning library is linear algebra, right, on all the associated programming. Which is the library you use a lot? It is sklearn, right? Make an attempt to understand what goes on inside sklearn library, right? Go and find out what is going on inside the library. You will find it is linear algebra, right? Our data sets are converted into matrices, and we use the concept of linear algebra to solve M and C, or it could be M1, M2, M3, C1, C2, C3, right? Different kinds of slopes and different kinds of error terms, so on and so forth, right? So this is how linear algebra is used in machine learning. Okay,